Okay, in this video, we're going to be discussing some ways to calculate the net present value using Python. The net present value measures the net value of an investment proposal in terms of today's dollars. All values are discounted back to the present, which recognizes the time value of money. The difference between the present value of the annual cash flows and the investment outlay determines the net value of the investment proposal, as we can see from these equations. So in these equations, the FCF variable is the annual free cash flow in time period t. It can take either positive or negative values. I0 with a negative sign is the initial cash outlay or the initial investment. R is the discount rate or the rate of return required by the firm to invest in the project. The rate of return required by the firm is the cost of capital or the average rate that the firm must pay for the funds used to purchase the capital project. This is also referred to as the weighted average cost of capital. Let's consider this project where we need to pay $40,000 to buy an investment at time zero and in the present. We estimate that from time one, this project is going to be creating $50,000 in the first year, $14,000 in the second year, $13,000 in the third, up to the end of the life of the project, which lasts for 5 years, where we're going to be creating or we're going to be receiving $11,000. Notice that that the end of the life of the project can include both the last cash flow, but also the terminal or salvage value. Just for the sake of simplicity, we're going to be considering that there is only the last cash flow created by the project. So the first thing that we do is going to be saving this information into our Python environment with these variables and setting the discount rate or the cost of capital. So the first way to calculate the net present value, and perhaps the most cumbersome and the least practical, is to follow exactly the first formula. Right, so we're going to be focusing first in calculating the sum of the discounted values of every single one of the cash flows received by the firm from the project, which range from T1 to T5. So we will call this variable the present value of the free cash flows that corresponds to this part of this equation. So the present value of the free cash flows we're going to be calculating is going to be equal to $47,674. But in order to calculate the net present value of the project, we still need to subtract the initial outlay or the initial investment. So the actual net present value of the project can be calculated very simply as the initial investment, which remember that we have already set with a negative sign in the variable I0, so we don't need to add another negative sign, plus the sum of the discounted values of all of these received cash flows by the firm from the project. So the net present value of this project is going to be equal to $7,674. So this is the first way, but not the most efficient, because we can do it quicker by using a for loop in Python. So to do a for loop, we're going to be saving these cash flows as a Python list from the initial investment minus $40,000 to the last cash flow that we receive, that is equal to $11,000. In addition, we save the discount rate, 12%, which is the cost of capital of the firm, into a variable called disc rate. So let's save these two variables. So let's do our for loop, the net present value, by initializing the variable net present value equals to 0 in order to be able to add all of the discounted values of the cash flows received by the firm from the project. So we say for I in range that it is going to be equal to the length of the cash flows. What do we want to do? We want to populate the net present value variable that we defined equals to 0 with the cash flows, every single one of them in this list from I0 to cash flow 5. Once that we have every single cash flow, we're going to be discounting it by dividing it by 1 plus the discount rate and raised to the power of I. Okay, and this is it. This is our for loop. So if we wanted to, for example, take a look at every single step that this for loop is performing, we can say print and round the net present value, in this case, how this for loop is populating the NPV variable. So we are going to be printing every single one of the steps. In the first steps, we are considering, first of all, the first cash flow, which is the initial cash outlay or the initial investment, equals to $40,000. And to this value, which is negative, we are adding the discounted value of the first cash flow received at time 1. So the result is this number. In addition, or following that, we're going to be adding to this number, we're going to be adding the discounted value of the cash flow 2, and so on, up to the last cash flow, which is going to be giving us a net present value equals to $7,674, which is exactly the same amount that we calculated in the first method to calculate the net present value. So there is no need to display all of these values, because in fact we have already the net present value saved. But if we wanted, for example, just to round this net present value to 3 decimal digits, then we have the value, or the final value, corresponding to the net present value, which is exactly the same one as previously calculated. Okay, so in order to speed up our calculations even more, we can define a function, right? A function that is going to be containing a for loop. So in order to define a function, we need to set a name. We can say that the name of the function is, say, calculate net present value, and this function is going to be taking two arguments. A variable that is called discount rate, and the other is going to be called the cash flow. So this is going to be the function. So inside the function, there is nothing new. We're going to be adding exactly this same information, but just with some minor modifications in order to match the arguments that we have set in the function. So we're going to be, again, initializing the net present value to 0, say for I in range that is going to be equal to the length of the cash flows. But notice that in this case, the cash flows need to, it is not going to be this variable. They need to match this argument that we have defined inside the function. So we're going to be saying cash flows. What do we want to do? Again, exactly the same thing. The net present value is going to be equals to the cash flows. Again, this needs to be exactly the same variable, every single one. So we define I, and we discount them by dividing it by 1 plus the discount rate. So notice that the discount rate in this case is already a variable that is defined and that is specific to this case. We're going to be defining a general one, which is going to be taking the name of the discount rate. Okay, so this is the one that we have defining is as the first argument of our function. So the last thing that we do is to raise that 1 plus the discount rate to the power of I. Okay, and that is it. So the last thing that we can do is just to get the results. We are going to be saying return, what do we want to return? A rounded value of the net present value to 3 decimal digits. And that is it. We have defined our calculate NPV function that takes these two arguments. Let's check if we haven't made a mistake and if it provides the value that we want. So the first argument we said is the discount rate. We have saved the discount rate in the variable disc rate. This is equal to discount rate, and the second is going to be the cash flows. So the cash flows are saved in this list, this Python list, from I equals 0 to the cash flow equals to at time 5. Okay, so we're going to be running this function and we can verify that this number is exactly the same one that we have been calculating with all of the methodologies to calculate the net present value. These are some examples, so you can practice with the development of for loops and functions to apply to the calculation of the net present value. But for example, you could just avoid all of the hassle of the work of defining your own function by using the library Numpy Financial. So we need to install Numpy Financial. In this case, I have already installed it in my computer. So the only thing that I need is just to call or to import that library into my Python environment. So in this case, we can see that I am going to be importing Numpy Financial as is convention, NPF. And if I call NPF dot, it is going to be giving me a lot of options that I have to choose from. So from all of those options, the one that I'm interested in is going to be the net present value, which is going to be taking 2 parameters or 2 arguments. The first one is going to be the discount rate. Remember that we have saved in the disc rate variable, and the cash flows that we have saved in this Python list as a Python list. So if we want to round that number to get the same, exactly the same value, we call the function round up to 3 decimal digits, and we run that cell, and it is going to be giving me exactly again the same number as previously. So what is the conclusion? It is that normally this net present value is positive. So the reject accept criterion for the net present value methodology is going to be the following. If the net present value is higher than or equals to 0, we accept the project. And if the net present value is negative, we reject it because it is destroying value for our company. So if the project's net present value is 0, then it returns the required rate of return and should be accepted. Just a note that the worth of the net present value calculation, and this is very important, is a function of the accuracy of the company's cash flows predictions, right? These are the predictions that the company made with regard to the amounts of cash that it will receive in the future. Okay, good. So there is one more thing. There is even another way to calculate the net present value. If we assume that the cash flows that the project generated can be reinvested at the discount rate, then the net present value formula becomes this one. So the net present value is going to be equal to the investment or the initial outlay plus the sum from t equals 1 up to the end of the life of the project of the cash flows compounded at the discount rate to the power of n minus t. N being the end of the life of the project, or the number of periods that this project is going to be performing. For example, in this case it is 5, minus t, meaning the time at which every one of these single cash flows arrives at the company. So this is going to be discounted by 1 plus r and raised to the power of the over capital N, which again, it is the life of the project, which in this case, it is 5. Okay, so we're going to be setting the information. So this is going to be the initial investment, I0, and this is going to be already positive, negative. We're going to be setting the cash flows that happen from time 1 up to time 5, and the interest rate, the discount rate, or the cost of capital of the firm. Now, again, if we want to follow exactly that same formula, this is exactly the calculation. This is the initial investment, which is already negative, saved as a negative value. And this is the cash flow one multiplied or compounded by the interest rate or the discount rate, 1 plus r, and raised to the power of the number of periods of the project, which is equal to 5, capital N, minus the time at which the first cash flow arrives, which is in this case 1. So 5, which is capital N, minus the time at which the first cash flow arrives, 1, it is going to be equals to 4. So this is to the power of 4. Cash flow 2. Cash flow 2 again is going to be compounded at the cost of capital, at the interest rate of the company. So in this case, raised to the power of n minus t. So n remains 5 because this is the life of that project. So n is 5 minus t. It is the time at which cash flow 2 arrives. So 5 minus 2 is going to be 3, and this is going to be raised to the power of 3, and so on. So this is the net present value, and let's just check whether this is true. What we are saying is true, that this is going to be giving you exactly the same amount or the same net present value that we have been calculated. So let's take a look at its $7,674. And this is exactly the same number. Okay, good. So we can again use the some functions in order to practice our Python skills to create a function that is going to be including a for loop. First of all, we're going to be importing Numpy as NP because we're going to be needing this library. And we're going to be defining the name of this function. This is going to be calculate NPV2. It's as simple as that. So this is going to be taking, instead of 2 arguments, just to make things simpler. It is not the only way to create this function, just the easiest way or the most straightforward. So the discount rate, it is going to be the first argument. Then we need the initial investment and the cash flows. So this function is going to be taking 3 arguments: discount rate, initial investment, and cash flows. What do we need to include? So we're going to be initializing the variable that is going to be called the discounted sum. Why is this the case? Because we're going to be focusing, first of all, only on the numerator of this equation. So this is the numerator, so this is exactly the first thing that we need to set. So the discounted sum, we're going to be initializing as 0 in order to populate it with our for loop. So we say for I in range that is going to be equal to the length of the cash flows. Remember that it needs to be exactly, the name needs to match exactly with the argument that we have defined in this new function. So what do we want to do this time? So the discounted sum, we want to populate it by adding the cash flows, but not on a discounted basis this time, but on a compounded basis by using the formula multiplied by 1 plus the interest rate and raised to the power of n minus t. So this gives us the multiplied by 1 plus the discount rate. Remember, it needs to match this variable that we have defined as the argument. And it is going to be raised to the power of the length of the cash flows, in this case, minus the array minus I plus 1. So we're going to be defining NP array. For example, we're going to be saying I and plus 1, okay, in order to be able to add all of these numbers: 4, 3, 2, 1, and so on. Okay. So this is the 1 plus the discount rate. Let's check that everything is in order. Discounted sum plus plus equal cash flows I multiplied by 1 plus the discount rate raised to the power of length of the cash flows minus NP array. And in this case, we're going to be including this inside parentheses. Okay, good. So what do we need to do next? Next, we are going to be calculating the net present value. So once that we have already calculated the numerator of this formula, then it is very easy just to subtract these the initial investment and to discount the sum of all of those compounded cash flows to the interest rate. So we're going to be saying that the net present value is going to be equal to the initial investment. Again, it needs to match with the argument defined in the function, plus, as in the formula, let's take a look, plus in the formula. Remember, initial investment needs to be given as negative, which is already the case in this variable that we're going to be substituting later, plus the discounted sum that we have calculated in here that has been populated by the compounded values of the cash flows added, the discounted sum. And this discounted sum is going to be discounted by 1 plus r raised to the power of capital N, which is going to be equal to 1 plus, what is this r? Is going to be, remember, it needs to be the discount rate and raised to the power of the length of the cash flows. Okay, very good. So this is all going to be this is the part of this is the result of the NPV. Let's check if this is correct. NPV, initial investment, in order to avoid any errors. And I'm seeing that in this case I'm making a small mistake, so this parenthesis should be here. So finally, we're going to be returning the result rounded to 3 decimal digits. Okay, so let's check, let's run this cell and let's check if this is going to be, if this function is going to be returning the same net present value as before. So let's call the NPV2 the function, Let's include as the discount rate is going to be equal to R, which is this one, 12%. Let's make sure that we have run the cell. Now we need the initial investment that is going to be equal to this initial investment, and finally the cash flows, which are going to be equal to these cash flows. So let's run this line of this cell, and this number or this value is exactly the same one as we have been getting all throughout this video. So it's 7,674, which represents a net present value which is positive, meaning that it's creating value for the company, and we should accept the project. So this is it. Thank you for watching this video, and see you next time.